Hello everybody and welcome to the stream. For those following after, welcome as well. Please follow me on Instagram and on Twitter if you haven't. Accounts listed there and also shared below. Today we're going to do something a little bit different. We're going to try and do mostly stuff in the webcam. We'll see how this turns out. Bear with me. This is a little bit of an experiment as we go. So, to get us started, so if you scroll down, I guess let's see. What are we building? Let's start there. So, a few months back, I created a little smart display, said when the next bus, the weather, stuff like that for the day. I built it with a Raspberry Pi and built a very terrible looking housing for it. Uh, Exposed wires on the back and all that good stuff. I believe this is actually a video of this thing working, so let's take a look real quick. Or no, just kidding. Just shows a video. So that's about as far as I got, and then COVID hit, and I left my makerspace, and so I didn't have access to the tools to do such things anymore, to build such a laser cut case. And so this project's been kind of sitting. I want to repurpose this screen, at least for the time being, maybe put something informational, something interesting on it, so I can keep that in my bedroom. I will be posting the parts list for this project, and the other required steps over on Hackaday. So if you're watching the stream, you can scroll down and click here on Hackaday. If you're on YouTube, you can check down the links below. This will pop you over to my page. If it'll load. Yeah, so this is my profile. I'll have a project listed up here around this project. And yeah, so what we're going to do today, if we switch over to the video, so this is what we got. We got a Raspberry Pi, we got a little screen, we can hook them up together, and we're going to try and make a little smart display. So this, yeah, will also be listed, all the parts needed here will be listed on Hackaday. The Raspberry Pi already has code loaded onto it. I think I'm going to do a fresh start actually, which might be a little hard to screen share. So actually, if you don't know how to get up and running with the Raspberry Pi, I suggest you hop over to Google. There's a ton of great resources on flashing SD cards and loading the operating system on there and all that kind of stuff. So if we queue this up, just to show, I guess, about where we're at, so we don't want to power it on just yet. I spent forever looking for this cable, by the way, just to get the angles right so that this thing can be compact inside the case that I'm eventually going to build today. So that fits like that. Cool. Move the screws out of the way for now. I think my charger just fell out of the wall. Yes, my charger just fell out of the wall. I will have to plug that in. One moment. Okay, so we got a light indicator. I think the screen should turn on. Yep, that's looking good. Let's see if we can make that more legible. I will be getting a little card so I can actually use my proper camera to do these kind of things in the future, but for now, this is what we got. Okay, so we have a login screen. We did have a login screen. So this is going to be a little bit wonky as well because I just have one keyboard, so I'm going to move the keyboard back and forth between my desktop and the Raspberry Pi. What just happened? It said login and now it doesn't. I wonder if it'll take, if I plug in my keyboard and type it all. Nope, there's nothing there. Oh, no, it's just taking forever. All right. Wonder if there's any way to not get glare. Where's that glare coming? The glare's coming from overhead. Let's see. What if I turn off my light? Does that make it better? A little bit. Looks still legible. A little bit more. So, oh man. This takes forever to boot up. I don't remember it being this slow. Okay, here we go. Cool. So, do. So we're opening up the browser, and it's not the most visible, but all right. I totally forgot that I accidentally killed the hosting for my app that is supposed to run on this screen. So yeah. So anyway, that's a Raspberry Pi hooked up with the screen. You can touch it. It's a bit slow. I was looking. So yeah, I guess I'll move the keyboard back because we don't really need anything else on there. So yeah, so let's make a to-do list for today. Actually, I know we already have this. I can show you what would run on it. If it was all up and running. So I made a little website in React. I mean, there's many different ways that you could do such displays on the Raspberry Pi. You could build a basic website. You could even find some service online. Let's see. Build a... What if you can customize this? Custom homepage, Chrome weather. So I don't actually know about any of these, but I feel like you could. It's really all this screen, this Raspberry Pi screen is it's an operating system. So you can open up browsers, you can run Python scripts, you can run any programming languages. It's like it's Linux, it's a desktop, has a screen. So like you could download this thing and just have that this be, which could be like says good morning to you, says the time. Let's see. Yeah. See, you could do this without any code. It looks like you could customize this page and then just have it start up. So you could have like your to-do, the weather, things like that. But anyway, I'd like to code my own site, so that's what I did. So we'll install our dependencies, and then we should be able to start this up. Ooh, a lot of dependencies. Cool. While that's going, I don't think we need the Raspberry Pi anymore, so I'm going to switch to a little be right back as I move the webcam around to point at me. Cool. All right. Just move these bits and pieces around me, and we are good to go. All right, so everything has been installed. We won't be spending too much time in code today. I think we're going to do mostly, I guess I'll show you what this is, and then we can get to the to-do list. Oh, I don't have a config. Oh, I'll be right back. Thank you. Yeah, sorry about that. 3D printer capacity solution. Thanks for. I totally had sound off. Man, I'm still getting used to this. Well, there's about 5 or 10 minutes where I was not talking. My bad, y'all. All right, so to fill everyone in, basically what I've realized is that I was looking at this screen and I feel like I'd originally assumed that the center of this set at this point and this point were the same, but it doesn't look like they are. So what I want to do is I actually want to take a measurement from these hole centers here and here, and that should better position these holes. Okay, let's clean up these dimensions real quick. Okay, so this is already 8. This is 8. That somehow lost its dimensions. That's already dimensioned. And then the height I said was 10.5. So a little tip for those using SolidWorks or newer to SolidWorks, if you just do the dimension from here to here, it'll always give you the center of the circle. Whereas if you hold shift and then click down, you can see that dimension snaps to a different place. And I'd rather have it be this outer edge here. So that's what I'm doing. I'm clicking there, and this is also 10.5. Cool. All right. So now the only things, we're always looking for fully defined. And what fully defined means is that nothing is ambiguous in the sketch. And so right now, this circle could still move around. We want to make sure that it's locked down. Like if you come over here, this doesn't move. It's very locked in because we defined, these dimensions here are enough to fully define the outer edge, but we want to define the circles. So this is going to be a bit of eyeballing. I don't need to be perfect with it. Looks like 85 millimeters. And that'll be from the half line. So we're going to use a construction line, which doesn't actually get included in the sketch, to set these centers. So this will be 85 by 2. I'm feeling a bit silly, but I didn't actually try and see if there is a schematic for this. It doesn't have a part number on it. I'm just going to write the information on there. Not it. Okay, that's it. Nope, that's not it. No schematics. Yeah, so sometimes I know that like someone has definitely done a CAD model for the Raspberry Pi, so we're not going to recreate that one. So I always try and save myself some work and see if these models exist, but this thing doesn't have a part number, which makes it a little bit hard. So we'll just finish this out. All right, we do know the circle is centered though, so we'll just drop another center line. And we forgot to diameter it, which we know it's 3, and now it's turned black, so it's fully defined. So we'll just repeat that process for these other guys. What is ambiguous about this? Is this not vertical? I'm confused. It's got a height. It's got a center line. Oh, interesting. That's not actually locked in anything. What did I lock this? Oh, whoops. Gotta lock it in the center of the circle, so I went the wrong way. So we'll go to center point, drop that in there, then make this line vertical, and that should make it fully defined. Okay, what did I miss in this one? Oh, that's not vertical, is it? Oh, there we go. Cool. Wrong way. All right, fully defined. So now, if I did that correctly, and that is, wait, really? 1.5 millimeters. Cool. So there is our screen. Yeah, it looks about right. Okay. Always eyeball your things. Let's rename this correctly. Not delete it. Consistency is key. Oh my gosh. Struggle bus today. Alright, so this is the screen. Alright, now let's go find the Raspberry Pi CAD model. We like to get ours from Thingiverse if possible. Oh man, that is detailed. So I like to avoid models like this because I don't need all this stuff. I don't need all these little capacitors and circuit elements and all this stuff. I really only care about these 4 holes. There's one more 8 here, I believe. Let me just disconnect the Raspberry Pi real quick. So what we care about are the mounting holes, which we'll be using to mount this guy. We care about where our USB cables come in, where power comes in, and where HDMI comes in. And this will slow down my computer, and I don't really want this. So I'm going to find a great model, useful for other things, but not for this. I probably actually want to go over to GrabCAD. Okay. Let's give it a whirl. Hopefully this model is not too bad. Okay, just going to do some dragging off screen. Let's see what we got. We got an STL. Oh, there's the light version. What's the light version? Is it that? I think, yeah, I think this is the light version, so it looks like there's less going on, which is good. Alright, so let's make a new assembly. We'll start to bring all this together, so parts make up an assembly. I'll drop the screen in here. Then we should hopefully be able to drop in. That's a womp. Maybe after this mesh. Wow. Yeah, so this is what I was worried about. This is exactly what I was worried about. I think this is the one we were just looking at. Okay. I don't know why, but this feels better. Perfect, yes, this is what we got. So I'm going to drag this off screen real quick because it never keeps me signed in. Okay, cool. All right. Oh man, let's close. Oh gosh, did I completely freeze everything? There you go. That file totally tanked. SolidWorks. All right, so all that's trying to recover. Okay, let's get out of here. Yep. Completely called that one. It tanked my SolidWorks. Yeesh. I feel like my computer should have handled that. Oh well. Okay. Moment of truth. Oh, this feels so much better. Yeah, that's a much simpler model. Oh, hey. I like the colors on this. It's like true to color. Okay, so let's insert our screen. Perfect. Okay, so we now have two of the parts that I need in this digital space. I think these various cables will come back to be a thing that I need to worry about. Like, so this is the screen, and this cable connects like that. And this distance here, I think I'll need to worry about as I'm doing a screen. So we'll need to think on that as we are doing our model. Just gonna grab some coffee. Cool. So I had this idea. Open up Paint. Tried and true way of conveying ideas on the internet. Cool. I do have a tablet on the way, so hopefully we'll be able to do these drawings more clearly in the future. So basically what I had in mind is screen being here, this being the outer case, and then kind of like a something like that. And then with like maybe a little spot here or in the back for the power case or for the power cable to go in and out. Um, I'm looking at the Raspberry Pi now, and so I'm thinking, so if we think about what I have here, it's like if we're looking at a sideways view, like if we're looking in this way, screen would be sitting roughly like that, and the Raspberry Pi would sit somewhere. So maybe actually it looks, yeah, this is going to be annoying to figure out how to get that little power outlet bit hooked in. Because the power cable basically is going to be like that. And so out of the top feels bad. If we go up like this, then it comes out the side, which is nice. But then we're going to have an HDMI or a USB cable coming out the top. Woof, this is going to be a little bit hard. I feel like I could just accept the fact that like the power cable is going to kind of disappear inside of this box, and if I can make some way that like the cable doesn't slide about, and like it'd be really annoying if I set this all up and then like the cable like unhooks itself and then I have to like disassemble this whole case. So I think this is the orientation, or no? Gonna get the HDMI cable attached. Cool. Okay. So there's like that. Actually, let's just hook up all the cables real quick. Bear with me one moment while I do that. Okay, so this is the grand total of the cables that we'll need. The power is the one that is going off screen. I'm just looking at how it sits right now. Okay, this isn't actually the worst. So this is how everything just kind of collapses in the back. Get my fingers out of the way anymore, or else it's going to fall down. Oh, there, if I do like that. That seems like what we're building towards. It's going to be tight. I think I don't even need to actually mount the Raspberry Pi to anything. Just give it some space to sit. Really just want to mount the screen so the screen doesn't move, so because the screen's the only thing that's going to be facing outside. I want to make sure that looks nice. So how do we want to do this? I was wondering if you could get away with like not having to use the screw holes. Like just using these bits out here and like stick it in somehow to the case. Okay, I think I'm going to do a quick and dirty SolidWorks model, which I might end up throwing away just to kind of think about this, because it's hard, as you saw, like to move things around in the air, to 3D conceptualize things in 3D that you're designing when it's also very kind of nebulous, very unsure. So let's just go roughly, let's start with this and see what we can do with that. So I'm going to make a box. And that box will need to be, so we're going to want, as I pointed out, when things stick out the side, you reattach these cables. So the screen is bigger than the Raspberry Pi, which means the screen is the main concern here. And we'll want to make sure that we cover this whole area with case, and then we'll want it symmetrical on both sides so it looks nice. So given that, with our ruler, the width of this should be, see, the screen is 12 centimeters, the side is another 4, so 12 plus 4 times 2 is 20, so 20 centimeters, or 200 millimeters. And then, again, the cables kind of stick out the top right here, so we'll want to account for that. So vertically the screen is about 7.5 centimeters, and it sticks out the top 2. So 7.5 plus 2 plus 2, 11.5 centimeters. Cool. So that's roughly the area that we need to fit the cables inside of. And then we'll need something further out than this. So this will make for construction. Didn't make anything for construction. There we go. Cool. And we'll want to do another square outside of this. And we'll say that the case thickness, I was playing around with this, I got some prints from the other day, and this is like a millimeter, and that like feels pretty good. I think it's a millimeter. Let me double check that with my calipers. 2 millimeters thick. Okay. The joys of having 3D prints are, is if none of this actually makes any sense, I can just reprint and kind of make tweaks as I go, which I do a lot. Sometimes I'll make several prints in a row, kind of slowly tweaking things until it does exactly what I want. Okay, so this is a thing that covers the screen. I don't want to add this angle on at first, just for this quick and dirty. So if we just make it very boxy, and it'll need to be accounting for all the wires. I'm just going to hold the Raspberry Pi like this and measure roughly that diameter to get a ballpark, and we'll say that's roughly 35. Double check that. Yeah, 35 makes sense. So here is a box that would house everything. Cool. So if we cut it out, we can then like throw everything inside a little cutout, and we'll see how that works. If we make that previous sketch, we're going to want to use that inner line for this, for the cutting out. And so you'll see how this all works out in a second. So just going to convert everything. Doesn't want to grab those lines. That's a bummer. I really can't highlight that line. Okay, that's fine. We'll just do a rectangle in here that we know is 2 millimeters from the edge. Cool. And we will now cut out. And if we go 33, so 2 less. Oh, whoops. So I did actually convert entities on the outside, which is not what we want. Just want to get rid of these outside lines that I did not mean to put in there. And now if we do that, now we have a box. Okay, so in this current pass, I'm making no considerations to the feasibility of 3D printing this thing. All right, so if we go back here, we can measure the distance between these holes, which is actually, let's just put the screen in there. As a first pass, we'll cut out. Draw on that surface, yep. So the screen width is 121. I want to give it a little bit of room, so let's go like 123. We'll give it a millimeter on each side. So it's 77, we'll add 2 to that, and that's the screen. And we'll want that position center, so if we just draw a line from here to here, and then take the midpoint of this line, intersect with the origin, now it's fully defined. And we will cut that through. Perfect. There is our most basic case. If we drag this in here now, alright. So the first thing you always drag into an assembly ends up actually being fixed, which is the screen, which is kind of, that's fine. So everything else moves relative to the screen, which the screen's kind of the shining star, so that's fine. So we will mate that. And mating is the process of kind of just lining everything up and saying this is relative to that. Oh, I did that backwards. Okay, so let's start by saying the front of the screen is parallel. No, not parallel. Coincident. There we go. But coincident in the other direction. Perfect. Get in there, and we want this edge to be parallel to this edge, which it assumes automatically. Or sorry, coincident, I should say. Same here. Cool. And there's our gap, which we said we wanted. Do we want it? I feel like if I double check my measurements and get the measurements just right, the screen will very nicely slide through and you won't be able to see any of the crap behind it. So the screen is 76 by 121. Okay. .76, we'll go exact. Let's live on the edge. Perfect. Cool. Let's make the screen black just so we can actually see it in contrast to the gray. Cool. Perfect. There's our screen, kind of flush in there, which means there's actually gaps. We'll need to add some gaps between here and here. So if we do a cut, cool. This lets us see inside, and you can see there's actually a gap between. To make it flush, we need to do something about this gap. So that's one consideration we should actually take care of now. So now that we're starting to actually really care about this, I'm going to double check that these measurements actually make sense. So get out the calipers and just measure the distance to the top of the screen is 6 millimeters, which we can come over and evaluate and measure and make sure here to here is, we have it as 7, so we're going to want to change that. I think this needs to be one less. Cool. So now we can come back here. This is another reason why I like to have things that I'm not necessarily printing available. I can just measure this surface to here, that distance is 4 millimeters, which means if we put a little plastic bit somewhere, somehow, in this case, so if we added like a little thing here, went like this, and made that 4 millimeters, and we'll do 4 of them, one for each side. Might even end up going with this box shape. I kind of like it. Okay, so this width has to be 8 millimeters. This is also 8. Cool. And the height of it was 8.5, and we know that from the dimensions that we took from the screen. Which, if I got this all right, which I believe I did, we should be able to go back, look at this screen, and these little bits should rest exactly on top of the holes within the screen, which they do. Okay, so it's a little off, but the center holes are right over, which is perfect. All right, let's get rid of this cut bit. Cool. All right, so now it's like, can the Raspberry Pi fit in there? Actually, I want to double check one measurement real quick. So the height of these cables that come out need to be at least 35 millimeters. Which means that the sides, the distance between here and here must be at least, yeah, perfect. I'm also giving considerations to aesthetics, but let's first see if the Raspberry Pi even fits in here. So if we say that this side is, we'll do a little offset. A distance from, just set it in slightly, which should be good, yeah. Cool. Let's see how far these two things are apart. So the highest part in the Raspberry Pi is the USB ports, and they are roughly 9 millimeters away from the screen, which is good. Cool. And then the power is actually on the other side. Yeah, I want this edge. Oh man. There we go. Mated to the other side. Perfect. Is that how we want it? So the screen has, oh man, I don't remember which side's the top. Oh no, here we go. The screen has HDMI coming out the right side. Let's power this thing up and see if the screen's actually the way I think it is before I put it in upside down. Which I guess doesn't actually matter because this whole thing's symmetrical. The box is symmetrical, I should say. So I'm just plugging everything in real quick. The screen turns on and... Okay. So HDMI is going to come out right here, and then that's going to wrap around in here, which will be good. Cool. Alright, so how big is this actual case? So if we measure the height of it, it is 119. Oh, I'm looking at the inches side. That's why it was so confusing. Okay, so it'll be that big, which seems nice. Okay, so I joked about this box, but this might actually be what it ends up being. Like I had talked about doing an angle, but I like the way I like the way it looks. How would it look with some rounded edges? There's a question. Let's come over, fill it all these things. Or let's fill it. Oop. Try this again. Okay. Don't know what's happening there. All right. Let's try that again. Cool. Oh, I missed a side. Oh, did I? Why does it look like I missed a side? Because I did. Oh, bizarre. It says it's there, but it's not. What if we remove it and put it back? Okay. That might be a bug in SOLIDWORKS. Cool. All right, so now we need to get a back case on here. And then we're kind of done. And we need a hole for the power cable to leave. So I ordered some cool bits. On Amazon, which are not here yet, which lets you use a soldering iron to take basically nuts and press them into. Oh, did not mean to open this up at all. Is Google down? That was weird. Okay. Actually, let's see if we can. Is this a video? Yeah, so this is it. You basically take your holes, you heat up. So this is a soldering iron. You heat up these things, you press them slowly down and in. Interesting. Just so yeah, and then you can run. So you can see there are threads in there, and then you can run your print, or you can screws, and this. Sorry, you can use screws through the back case, and I just got some of those. I only have the nuts at this point, but not the screws, which is a bit of a bummer. Which I would be nice to do here to these four holes. So maybe before I actually print this model, I will do some testing around with it, because I do have a few screws, not enough screws that I need to complete this project, but I do have the nuts, enough of them, so I could test nuts and screws and things, and maybe that's what I'll end up actually doing. So if I do that, we'll probably circle around for another video, but don't want to demo 3D printing while live streaming. Cool. So if we're going to assume that route, we're going to want to do some additional extrusions up out of the corners. So basically we'll put little squares here, similar to this guy, these 4 bits. We'll make them hollow. The squares, they'll have a little circle inside. And then we'll add a back plate, and then the back plate will have screws through it. So let's see. Let's sketch here. We'll add some squares out of the corners. Just make all of these equal to make this simpler to do. Don't want you. Okay, so these are equal. Just got to do one dimension. Cool. And then if we extrude out, and then last bit, we'll want to add some little holes here, but we'll do that later once I actually play around with the nuts. Because as I was observing in the video that I closed, you saw the guy was like printing out some square plastic bits and then putting holes in the middle and then pressing down. So I'll need to do some experiments to figure out how big to actually make these holes. So I wonder if I can get away with just using this model. So we'll make a copy of it. So we don't need these for the back of the case. We don't need the hole. The actual extrusion is not going to be as high. Maybe like 2 millimeters thick. I don't think we need this. Oh, we lost everything. Okay. Well, we have a starting point at least. We have this guy, which is 2 meters thick. Okay, I might actually want to split screen these two out as I'm doing this. So let's put this right here so I can look at it. Okay, so let's fill out the edges real quick. Apologies for the barking. Okay, so I think for a fillet radius of 3 millimeters, the backside, I believe these were 3, right? How does 2 look? Alright, sorry, I'm going to close the windows. Be right back. Okay, sorry about that. Alright, yes, so I believe I changed these to 2, right? Yeah, okay. So the reason this looks all wonky is that to make it actually look good, the radius needs to be at least as large as the thickness. So if we drop that down to 2, you'll see that it's actually properly curved now. Cool. Okay, so there's a back plate. What was this sketch? This sketch had these coming out an 8mm square out the edge after the 2mm thickness. Okay. So we're going to draw one side, one corner for kind of reference. And then hopefully I'll be able to use a pattern to match all 4 other holes. Don't know how I want to do this. Okay, so we have construction lines. Oh gosh, hold on. I think I was drawing on the wrong surface. There we go. Okay, cool. So now we know that this is 2mm from the edge. So the dashes means these will not actually be part of the final sketch, but they're just going to be for reference. And then it was an 8mm square from that point. Ooh. And then these should all be for construction as well. And then the center point is going to go on there. So if we draw a center line across, we can now sit this in the center. Perfect. Don't know what this dimension is going to be yet. I feel like, let's go 3mm. I will probably come back and revisit this to make it a little bit more pretty. I think I might want to add like, so the screw itself will pass through that hole, but maybe depending on the screws that I get, I want to make sure that the head is flush against the surface and not sticking out. So I might add another larger circle that doesn't cut all the way through. Okay. So now if we add some more construction lines for reference, we should be able to take this circle because everything's fully defined. So the cool thing about construction lines is like you just assume they go to infinity. So like this doesn't actually matter because it's just really all we want is a vertical line. And that's what this is. It is a line that is vertical. It is for construction only. I think if we do infinite length, it goes both ways. Yeah, that actually would make it a little bit clearer. Oh, now it's underdefined. Interesting. Oh, because it's somehow not connected anymore. Anyway. Oh, that makes sense because the point that was connected is now gone. Because it's to infinity. But anyway, not so important. We're going to take that circle and do a, no, linear pattern or mirror? Mirror. Entities to mirror. And we want to mirror them about this. Nope. Can we do 2 mirrors at once? No, you can do only 1. Okay. So we'll do this mirror, and we will then do another mirror. And we'll mirror them about the vertical this time, which now gives us the 4 pattern that we need of holes for screws. They're fully defined. And then we should do our extruded cuts through all. Perfect. Looking good. Looking good. Okay. I think that's all we need for the back case. And we should be able to drag that into the assembly now. Cool. So we will mate everything up. This line and this line and this line are the same. Interesting. This is actually kind of... That's... Okay, I'm going to need to wrap my head around this one. Okay, let's finish mating and then we'll come back to this. Cool. Okay. I don't actually know what to do about this. Let's see. Is there a way I can, like, force this fillet to, like, also be this point? No. Do I have to extrude it out further? That's a sufficient amount to prove this point. Oh, and then I'd probably have to round this corner as well to make this work. Okay. So we don't want to go 12 out. What if we just do 2? Let's go 4. And then... There we go. I'd rather not print all this material to like have this fancy little look. What if we did like 0.5 millimeter? Oh gosh, no. Sorry, we want 2.5 millimeters. Yes. Look at that. Oh. What did I do here? Oh. Okay. Did this not go back to 2.5? It didn't. Hopefully that fixes the errors in here. Yes, perfect. Okay. Broke something in here. Are these mates not valid anymore? These mates not valid anymore. Alright, so we're going to delete those and try and mate these things together again. What is still valid? This can still move around, so I want to make this line and this line and mate them. Perfect. And then this outer line, oh gosh, I think this line. Hopefully that's the correct line. Sick. Okay. That's a case. That feels good. Oh, man. If anyone in chat has a question, feel free to ask. So it looks like, thinking about the power cable, I just want to probably throw in a little hole. Probably look nicer coming out of the back of the case than the side. I hate seeing cables when possible. So if we come in and just do a little cut, and the cable can come out. That feels good. Okay, so if we look at the cable is 2 millimeters by 3. Oh gosh, might want to get exact with this. 1.8 by 3.8. That's, I actually got those backwards. Cool. So now we're going to figure out a place to put this little thing. I want to do this. So one of the issues is I want this to kind of be pressed in to the case. Because I don't want the wire to just, I don't want you to be able to pull the wire from the outside and have it disconnect from the Raspberry Pi. So if we press it between the walls of the case, it can't actually get out. Not too tightly, we don't want to sever it. That'd be an issue. But or maybe it doesn't matter. I think it's fine without. So we'll make it so that it's just large enough to fit the cable through. And the cable is about 13 by 8, 13 by 9. Alright, so we'll make that 13, we'll make that 9. And let's just have it centered, because symmetry is nice. And we'll want it a little bit away from the edge. Cool. That seems like a good spot. And then we'll extrude that through with a cut. Perfect. Okay, totally just did that on the wrong side. Let's edit that real quick. We just delete, oh gosh. We just do that dimension from the other side. Perfect. I'm wondering, I feel like we might want to also mount the Raspberry Pi into the back of the case, which will be another exploration in screw holes. Sorry, there's someone outside. Okay. So if we look at the hole pattern on the Raspberry Pi, which we now can just look at, so these 4 holes straight across, 49 millimeters apart. 49, interesting. Oh, they are squared, or not squared, rectangular. So this shouldn't actually be the worst. Okay, let me jot down these numbers real quick. So long ways 58, short ways 49, and diameter 2.75. Okay, so now if we go to the back case, just change the transparency so I can actually target the back case. Okay. Cool. So let's draw a little rectangle. And this will be where the mounting holes go. So 58, 49. Make these for construction. And then we'll want little squares on each of these ends. Or rectangles, not sure which one. Okay, so sides are going to be equal on all of these. We're going to do that little trick again that I showed you before. Set them all equal, and then you only have to dimension one side. Cool. don't actually know where I want to position these yet. So I think the nuts that I have, their depth is maybe about 4 millimeters. Oh, that seems like a lot. Or did I totally just not edit the number? I didn't edit the number. Okay, that feels better. Cool. Okay, so how does this look if... I know there's a way to hide. Hide. Cool. Okay, there we go. We don't need the screen either. We'll want to get rid of mate so that we can actually, we don't want it coincident with the bottom surface anymore. And this will let us move it up. Alright, so if we put it like, oh, we also don't want it flush against the back anymore. So I think the distance is 4. Oh yeah, that should be where we want it. Cool. And then it now sits flat. Perfect. And then if we bring back the screen, how does that look? That looks good. I think these need to move over the distance between this surface and that surface. So if we measure from here to here, see, because actually I'm noticing nothing comes out of here. We have HDMI, we have power, and we have USB, which means this should go as far to this wall and as far to this, because there's nothing coming out of the bottom either. Leave some space for that. So we actually don't want this surface. Let's just move it all the way to the right. This is very much eyeballing, by the way. But the joy of throwing it all into SOLIDWORKS is you can eyeball it. This is just guessing. Okay, so now, assuming that's gonna would sit right about there. Space is still nice. I like that. Okay, let's bring the case back. Let's bring it in a transparency. Perfect. Wow, that actually looks pretty slick. Cool. So I think that's it for this for the time being as a first stream. Before I peace out, one more call for questions and things. Actually, let's look at the do. So design a case. Come back to kiosk mode later. So let's say this is for stream 531. We'll do another stream. Not sure when. We'll see. Cool. To do done. Case assembled. Yeah, so I will do another stream, post another YouTube video, or this stream will become a YouTube video. I will post updates and project summary, parts list, all that good stuff on Hackaday. It's a project. Link down below for Hackaday. Check it out. I'm going to go do some experiments with press fitting the nuts that I got. Excuse me. And then we'll take the learnings back and see what we can do with this guy. So, till next time, I will catch y'all.